Hey, it's Kelly here, and today I'm going to be introducing you to the first of three very important topics that we call the Big Three. When you create a class, the system provides some functions to go along with that class for you. For example, you can do things like create an object from another object, or set one object equal to another object, or when an object goes out of scope, the system automatically destroys it for you. These are the three parts of the Big Three, and we call them the copy constructor, the assignment operator, and the destructor. Today I'm going to be talking about the copy constructor. Now for simple classes, the copy constructor that the system provides for you works just fine. However, when we start to have more complex classes, particularly classes that have dynamic memory, we need to implement our own because the system's way of doing it will cause you some errors. Before we take a look at the copy constructor that the system provides for you, let's talk a little bit more about what the copy constructor is. So the copy constructor is named as it is because you're basically constructing an object by making it a copy of another one. So we've already discussed that it's called when you have a statement like cube B and pass in A as a parameter. However, the system may call it in certain situations. For example, if you pass a cube into a function by value, the system needs to copy that object outside the method into the object that's the parameter local to the function. The copy constructor will similarly be called if you're returning an object by value. So now that you have an idea of when we use the copy constructor and what it is, let's take a look at basically what the default copy constructor that the system provides you would look like. So here I have the cube class that we've been working with. And you'll see here, this is what our cube copy constructor looks like. Let's just take a look at the function signature. It's a constructor, so it goes by the name cube, and then it takes in one parameter, a constant cube passed by reference. Why do you think we need the reference in this case? So as we discussed, one of the times the system will call the copy constructor for you is when you're passing an object by value. So in this case, if we didn't pass this cube by reference and we passed it by value, the copy constructor would be called in passing a parameter into the copy constructor. So things would not work properly. Now we also have the const. Why do you think we need the const in this case? So the const in this case is just ensuring that this cube object that we pass in as a parameter doesn't get changed at all within the function. And this makes sense because if we're really just making a copy of this cube, nothing within the cube should change. So now let's take a look at the actual meat and potatoes of this function. And you'll see that we put all of the actual copying that's done into a helper function. This will be useful for reasons that you'll see later, but trust me, it's worth your while to do. Here we have the copy function. Again, we're passing in a constant cube reference. This is the code that the system would provide for you. In this case, I've explicitly listed it so that you can see it. What you'll see is that it's doing an item-by-item copy of each of the member variables of the cube class. So it's setting the edge of this new cube to be the edge of the other cube, the number of faces to be the other's number of faces, and face names to be the other's face names. Just as a reminder, face names is a string pointer that points to a dynamically allocated array of strings. Really quickly, now that you've seen how the copy constructor is implemented, look what our constructor does. It takes in a double edge length, assigns that to be edges, creates 6 faces, and creates a new array of strings with top, front, left, back, right, and bottom as the names. So keeping that in mind, take a look at the code that I have here. So first I'm creating a cube A with an edge length of 5 with that constructor that we saw. And then I'm using the copy constructor to create B, a copy of A. Then I'm setting A's first space to be lid. And then I'm just printing out both of the cube spaces. What do you think this code is going to print? All right, let's see what happens. So if we make this code and we run, so the copy constructor is called when we're creating B, and then A spaces are lid, front, left, back, right, bottom, and you'll see that B spaces, the first one also got changed to lid instead of being top. But if you remember, in the code, we only changed A space. Why did this happen? Well, if we remember what our copy constructor did, it went item by item, copying the values from one cube to the other. So when it got to this face names line, Face names was a pointer to an array of strings. So it copied the value that was in one pointer to the other pointer. And we know that pointers just contain an address. So therefore, both cubes pointed to the same set of faces. That's why when we changed one cube's face name, it changed the other cube's face name. To work around this, we need to do something called deep copying the values from one cube to the other. Let's take a look at what this looks like. All right, so I'm going to copy over the correct cube code. So now if we take a look at our copy constructor, edge and num faces are copied by value again, which is fine because they're just a double or an integer. But then face names, we see that we create a new dynamically allocated array of strings and then copy over the strings by value. So now when we run this code, if we make and run, we see that the copy constructor is called again, and in this case, only cube A's face changed to lid. Alright, so now you know what the copy constructor is. Keep in mind what you learned here when you watch the videos about destructors and assignment operators. Thanks!